Okay, guys, so our introduction to functions. Most of this should be a review, but still, if you print this out and you cut it around the outside, these tabs fold in and you can write the titles on the outside. It was a foldable that I used to use in classroom on our notebooks, but otherwise, it's a great graphic organizer and you can just hole punch it and stick it in your notebook or put it in your folders, however you're maintaining your notes. All right, so the upper left corner, we're talking about graphs. So not we're looking at all the different ways to tell if something is a function or not, and this is just looking at a graph. So vertical line, so a vertical line test is what we're going to use, and vertical is up and down. So vertical line test, and that means a line going this way. So up and down vertical line test, and that line's going to slide back and forth. So if a vertical line passes through the graph more than once, it is not a function. So if it touches the graph more than one time, no go. So on here, we're going to put a graph is always a relation. We're going to get the domain and the range for each, but in this case, we're just going to look at like sketches for our graphs. We're not going to worry about the domain and range right now. So if we have our x and our y axis, and we have a diagonal line, like a linear graph, if we put our vertical line on that and slide it left and right, at any point will it touch that diagonal line twice? It will not. So that means that it is a function. Quadratics, so the parabolas. Again, if I take a vertical line and I slide it right to left, maybe you've had a teacher that's used a Post-it note. So if you take your vertical line like this and you run this way, at any point does it touch that graph twice? And if it does not, then it is indeed a function. Another popular one is the absolute value function. And again, so we run our vertical line left to right, it will only touch it once all the way across from left to right. Some not functions that you could think about, again, on your x and your y axis. A circle. So our first vertical line, without even sliding it, we see that it touches it twice. How about a vertical line in general? So again, if I slide my red vertical line test to the left, it's going to hit that line more than once. It's going to hit it indefinitely. It's going to come right on top of it. So that means that it is not a function. If our parabola gets turned on its side, again, it's going to touch twice with our vertical line test, so not a function. Anything that, if it's a dot below it, so even if you drew, and it was a line that went from here over, so not even a full line, but then there's a dot down here. If at any point there is another piece of data where that line touches twice, it is not a function, okay? So that means it touched it twice. It's not a function. So maybe it's a step function. But if it touches it twice, then it is not a function. So moving right along, if the x values of ordered pairs. So ordered pairs is going to be that x and that y. So x, y. And they're listed usually with squiggle parentheses on either side. So x values of ordered pairs, if they repeat, then it is not a function. So repeat, not a function. If there's an x value and a y value in each ordered pair, it is a relation. So x cannot repeat. X cannot repeat. So if I was to make a list in my functions, and our coordinates, our ordered pairs, would be listed with our x value first, y value second, x value first, and I'm just making these up, y value second, x value first, y value second, and then the squiggles just list is what those squiggles mean, is that you are writing a list of ordered pairs. So looking at these ordered pairs, if I look at my x values, so 3, 2, 9, none of them repeat, so it is a function. Now, we are going to do domain and range on this one because it's fairly easy. Because again, you're looking at all of your x values. So your domain is all x values. So it's always your x values. So that means our domain, we could write it as a list, would be 3, 2, and 9. Or we can write it in interval notation or in notation, and that's going to take your smallest one and then your largest one. If it was if it was a straight line that went through those dots, then it would be everything greater than and then everything less than 9. So if that was a straight line that went through each one of those points, then indeed it is a function, and it would, the domain left to right would go from 2 to 9 if they were actually like attached to each other. If they were loose points, then your domain is just written like this. It's not between 2 and 9, because between 2 and 9 means 2, 3, 4, 5, 6, 7, 8, 9. All right, and then so our range is our y value. And if you get these mixed up, it's alphabetical. So we know X comes before Y and D comes before R. So again, in this, now I'm looking at my Y values. So 4, -6, and 2. And this is just discussing our range. So -6, 2, and 4. And I just put them in numerical order. It doesn't matter what order they are. The range is just stating that those Y values are used for this function. All right, so to write one that's not a function, that means we have to have an X value that repeats. So let's do 3, 4, that's one coordinate. 4, 1, it's another coordinate. And then how about 3, -2? And again, remember, this first is our x values. And as far as deciding if it is a function or not a function, that's all that matters is their x, and x. And then the y, it only really matters to the conversation of range. Or in this point, you might have a question that says, what's your output? So output is y, input is x. So your input, and that'll make more sense later on, but for now, just if you can start to remember those words. So x is input, y is output. So in this case, my domain would be a list. So 3 and 4, and you don't have to list 3 twice because it did repeat itself, and that's why it's over here in the box with not function. So it's not a function because x repeats itself. And then our range is going to be our list of our y values. So we have a -2, 1, and +4. So when it's just a set of coordinates, if it asks for domain and range, you are just listing the x values and the y values, especially if they're just literally speaking to dots on a graph, listing just coordinates. All right, so if the x values in a table are repeated, it is not a function. So the exact same thing as your coordinates, because tables really are coordinates. So if I took the ones that we had up here before, we had 3, 4, 2, -6, 9, 2, and then we'll do 4, 1. So a function, again, as long as x does not repeat, then it is a function. And given in this way, unless noted that it is attached and that it is a line, your domain, so your domain again would be your x values. So we've got 2, 3, 4, 9. And then your range, just like x, y, dr, your range is going to be your y values. So -6, 1, 2, 4. Then not a function, so that means somewhere we have to have a repeat up here, so we could use the one we had before, which was 3, 4, 4, 1, 3, -2, and then it could be 1, 2. So again, these repeated in the x values. It does not matter if they repeat in the y. It's just the inputs that matter. So input is the only place it cannot repeat. Cannot repeat in the x only. Y is allowed to repeat. It's fine. So for our domain for this table, we would have 1, 3, 4. And then our range for this table would be -2, 1, 2, and 4. So when they ask for domain and range, it's asking what x values and what y values does this table, this line, this list of coordinates actually encompass. Now, over here the diagrams. So in diagrams, this is also called mapping. So maps, so this is your mapping corner. Also called diagrams. Just different teacher, different worksheet, different question writer. So if an input maps, so your input is your x value, to y, which is our output, more than one time, that means that it would be a repeat number. That means that 4 would happen twice. So in this case, for it to be a function, that 4 can only go in a direction one time. And the 3 can go to the -7, that's fine, as long as there's not 2 arrows coming from your input or your x value. And then Have them go and then crisscross everything. But as long as you have one arrow coming from every x value, then it is indeed a function. And you will see these sometimes, they'll have circles around them, maps around them. Yep. And then for not a function, just like the previous, the input cannot repeat to a different output. So that means your x cannot repeat. So for this to be not a function, and we'll go and put the circles around it, because that's probably how it is notated more times than not. If 1 goes to -1, just for fun, we could do 3 to 2, 4 to 5, -5, 9 to 3. Now, at that rate right there, it is a function. But as soon as I go from 4 and take it also to 2 or any other number, so in that case, you see the 2 arrows coming away from the 4. So that means that 4 is used twice. That input value 4 would be twice. Then it is no longer a function. So the biggest takeaway is x cannot repeat. And circling back to our graphs, remember, graphs are ordered pairs or a table as well. So as soon as I see this, if I call this, let's say this is 4, 0. Well, down here is going to be 4, -3, or whatever number it is down there. So then the 4 repeated. So that's not going to work. So if I used, this is 2. So 2, 3. And this could be 2, -3. Again, your output, your input, your x value is repeating if the vertical line touches it twice. Versus over here, we're getting all positive x values as it moves along and positive y or negative y values as it goes, negative x values as it goes to the left. So positive x values to the right, negative to the left. There's not a point where it cuts back and your coordinates would have the same x value. It's just a difference in the way that they illustrate your data, whether it be in a line or in a table or in ordered pairs or in a mapping. But at the end of the day, x cannot repeat. Input values cannot go to more than one output value. All right, guys. Hope that makes sense. You got to fill it in.